Hello everyone. Today let's solve the problem number 51 n queens, right? So today let's solve the problem this one n queens. So what the question states here, the n queens puzzle is the problem of placing n queens on a m into n chessboard, right? So such that no two queens attack each other. So no two queens should attack each other, right? So let me come to the example part. We need to place n queens on an n into n chessboard so that no two queens attack each other, right? So no same row, no column or diagonal, right? So here you can clearly see this cannot attack this queen, so this is fine. I'll just show you once if you don't know the chess part. So queen can move this one, it can move horizontally, it can move vertically, it can move diagonally as well. Left diagonal, this one right diagonal, bottom left diagonal, and the this one bottom right diagonal, right? So it can move this one up and down as well, queen, right? So it can move any steps, right? So it shouldn't be able to attack another queen. See here, it is not able to attack this queen. Here it is not able to attack this queen as well. It is not able to attack this one as well. Same goes with this one as well. So it can move in this direction, this direction, this direction, and here as well, right? So any number of moves can be done. So it cannot attack. So it is placed in such a way that it cannot attack one another, right? So what we need to do here, so we must return all the possible board configurations, right? So we must return all the board configurations here. So we have been given n equals 4. So here we have been given n equals 4, right? So they have shown us wonderful example here, right? So we have to show all the this one, right? All the possible, what do we call, board configurations, right? So see here, 3, this one, this cannot attack this one, it goes only here, it cannot attack this one, this is fine. Now this one also, this cannot attack this one, what do we call it, just goes here, and this one here, this one and this one, second one cannot attack this one as well, this one as well, this one as well. Same goes with the third one. Third one can move this one here, here, and here. It cannot attack anything. And finally, the fourth one, this can move here, here, straight, right? So it cannot attack any queens. So this will be the answer basically, accordingly with the question, right? So now you can just consider the example to, and you can just see it in the same way, right? So let's move on with the approach part here. If you would have understood the question. So let's move on with the approach part. So first we need to place the queens row by row, right? So we need to place the queens row by row. Let's start with the row 0, right? So initially let's start with the row 0. Just give me a second here, 1 second. Yeah, let's start with the row 0 here. For first, what we will do, we will place the queen. First thing I want to tell you here is we will be going with a backtrack approach here. We will be going with a backtrack approach or the recursion, right? So backtrack uses recursion. We'll be going with a backtrack approach. Just keep this in mind, right? So first we will place the queens row by row. We'll start with the row 0. For each row, we will try all the columns first, if placing a queen is safe or not, right? So we shouldn't place in the same column or the diagonal. We have to place it and move to the next row. That's what we need to do, right? So if we reach row n, we found a valid solution, and then we have to record it. If we are stuck, we will be backtracking, right? So that is the reason I said we'll be making use of the backtrack. If we are stuck, we'll be making use of the backtrack, means we'll remove the queen and we'll try the next column, right? So we have to repeat until all the possibilities explored, right? So let's start with n equals 4. Let's start with n equals 4, right? So first let's go with the row 0. So this one, let me represent this one as row 0. So we will place the queen at the column 1. When we place the queen at the column 1, this one I'm speaking of. So dot is nothing but, so this one, dot queen dot dot, this one. Fine. So next we will go with the row 1. Actually, what we will do, we will we are safe at the column 3, right? So now we are safe at the column 3 because queen can move diagonally, left diagonal, right diagonal, bottom left diagonal, and the bottom right diagonal, and it can move left, right, up and down as well, right? So we can just place the queen at the column 3 now. So this one we cannot place here, we cannot place here, We cannot place here as well. Queen can move, so we can place here, right? So we can place here. This is fine. So now we will go with the row 2 actually. Row 2. Now what we will do, it's safe at the column 0 basically, right? So here, this one, column 0 itself, first one. So this one also cannot attack. So this queen we have considered in the row 1 basically. This is row 0, row 1, row 2. In the row 1 we have considered at column 3, queen at the column 3. So this one also cannot attack this one, right? So this is safer actually, right? So this is fine. Now we are left with only the last queen here, last row here, sorry. This is row 3, and the queen is safe at row, this one, what do we call, column 2. When I say column 2, this is column 0, column 1, this is column 2, right? So this one we will give queen here. So this queen also cannot attack this one, this queen also cannot attack this one, and this queen also cannot attack this one, right? So they cannot attack one another, so we can just place the queen over here, right? So now we are done with this one, right? So first solution we have found, first solution we have found. So this is same as this one I showed for this one, right? So first solution we have found, this is same as this one. So now what we will do, we will backtrack again. We will backtrack again. I cannot show all the backtracking methods, right? So we'll backtrack again to explore the other possibilities, right? So to explore the other possibilities, we'll do the same thing, right? So we'll check with all the other possibilities and we'll be getting this solution. So we have got the first solution. This, I'll just mention first solution. I'll just leave it to you to find the second solution basically, right? So we'll backtrack all the other possibilities and then finally we'll be up with this solution as well, right? So this is the first solution and I'll just mark this one as second solution, right? So this one is nothing but second solution. These are the two solutions that we get. See here, this one goes here, here, here. It cannot attack any of the three queens. Same goes with this one. This one can move here, this one down and up, and this diagonal, right? Top right diagonal. So it cannot attack any other queen. So this one, it'll move here, here, down. It cannot attack, right? So same goes with the fourth one as well, which is placed in the row 3. Row 0 is row 1, row 2, row 3. This is row 3, right? So this one is row 3. So same goes with the row 3 queen as well. So this one goes here, here, left, right, and up, right? So it cannot attack any other queen. So this is also the this one also we can consider. This is also one of the possible solution in simple terms. So this is the second solution, right? So I hope the solution is completely clear, man. So this is how we will be finding the solution basically. These two solutions will be returning as output. So the output that we got here is this one. So we'll represent the same thing in the form of array here. So this one, and the second solution, this one, will be representing in the form of array, this one, right? So these are the two solutions that we got, which is equivalent to the output that they have mentioned for the question 1, within the question 1, right? So our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be big of n factorial, right? So the time complexity would be big of n factorial. Why it is n factorial here? Because for each row we will be trying all the columns and we will be backtracking recursively, right? So overall time complexity would lead to big of n factorial, quite obviously. And what will be the space complexity here? The space complexity would lead to big of n square, because we will be making use of the board for the board basically, and for the recursion stack also takes up to the big of n, right? So this one, depth of the recursion basically. So overall space complexity would lead to big of n to the power of 2, or n square, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n factorial and big of n square respectively, right? So now we are done with the this one, complexities and the approach part. So we are good to write the code. Let's start writing the code. Initially, let's do one thing. We have to store the final result for the solution, right? So that consisting of all the solutions, right? So I'll just go with list, array list basically. So let me go with the list. So this one will be string. I'll just consider the result variable. So this one will be new array list. This is fine, right? So the next one would be chessboard. This one will be char. This is also fine. This one will be board equals new char. So this one will be n and n. This is fine. So the next one would be the for loop here. For loop, this one would be for int I equals 0, I less than n, I plus plus. So this is also fine. So within the for loop, let's initially go with all the cells which are empty, right? Let's fill that one by making use of the arrays.fill. So I'll just go with fill board of I. So we are filling with a dot, right? So I'll just give here comma dot. So this one we have to give within the strings basically. So I'll just give dot here. This is fine. Next thing, as I've said, we'll be making use of the backtrack, right? So we'll be making use of the backtrack basically. So for that, I'll just make use of the helper method backtrack. So let's write that one first, and then let's make use of the backtrack helper method within the main function solve n queens, right? So this is fine. Let me go with a private void backtrack. So this is fine. This will be int row and char. So this one will be board and this one will be list. This is also fine. This is also fine. String result. So this one will be int10. This is absolutely fine. So within the backtrack function, so first thing is if all the queens are placed, then we have to convert the board to the string format and then add it to the construct, right? So then we have to add that one to the construct basically, or add that one to the result in simple terms, right? So we will be making use of the construct helper method for this one, right? So again, if all the queens are placed, then we have to convert the board to the string format and add that one to the result, right? So let me go with simple if condition here. Row equals n, then I'll just go with result dot add. So before making use of construct method here, so let me write the helper method construct first. So I'll just go with private. So this one will be list string. So let me make use of the construct here. So I'll just go with construct method here, which consists of the parameter board. This is fine. So within the construct method, so let's convert the 2D board into the list of strings, nothing but list. So this one will be a string. So this is also fine. So this one will be path equals new array list. So this is fine, man. So this is fine. Next, let me go with char. Uh, this one will be row. This one is of pod. So this is fine. Now within the for loop, let's add this one, right? So I'll just go with path that add. So this one will be new string of row. This is fine. Uh, let's return the result. Sorry, let's return the path. We need to return path, right? So let's return path. So this is fine. Now we can just make use of the construct within the backtrack method, right? So I'll just go with the construct. Just give me a second here. So if row equals n, I have given the result dot. So I'll just make use of construct here. So construct of basically we have to pass the board as parameter. So this is fine. We're just converting the board to string format and we are just adding that one to the result. We don't have to return anything yet. So right. So just give me a second here. Just give the return keyword here. Let me come out of this one entirely. Now we have to try every column in the current row as per the approach that we discussed, right? So I'll just go with a for loop here and column equals 0, column less than n. So this one will be column plus plus. So this is fine. Now within this for loop, after trying every column in the current row, what we'll do, we will check if placing the queen is valid or not, right? So what we are doing, we'll check whether the queen is safe in simple terms, right? So for that, I'll just make use of the another helper function called isSafe, and then let's make use of that isSafe helper function within the main method, right? So I'll just come here. So let me give private. So this one will be Boolean. I'll just go with isSafe. So the parameters will be char. So this one will be board as well as row, and again this one will be column, and this one will be n. So this is fine. So first let's check the column. Let me go with the for loop here. This one will be int I equals 0, I less than row. So this one will be I plus plus. So this is fine. If board of I column equals q, then we have to return false, right? So accordingly with the condition, or accordingly with the approach that we discussed. So I'll just go with board of I, this one column, if this is equal, we are making use of the comparison operator here. So this one will be, if it is equal to q, then we have to return false. Queen cannot attack, right? So it is not safe. In simple terms, it is not safe basically. So next we have to check upper left diagonal. We have to go with the upper left, means top left, top right, bottom left, and bottom right. So that's what we'll be doing. Now first we went with checking the column. Now we have to check the upper left diagonal, right? So let me copy the same thing and make the necessary changes here. So same thing here, copy, paste, then again let me copy paste. So this is for the upper right diagonal, upper left and upper right diagonal, right? So this is fine. Now for the upper left, so I'll just go with int I equals row minus 1, and this one j equals column minus 1, right? So this one we have to go with I greater than or equal to 0, mm, and j greater than or equal to 0. This is fine. Now we are left with this one I minus minus comma j minus minus. So this is fine. Now let's write the simple if condition. If board of ij, so I'll just keep here, if board of ij this is equal to q, then we will return false, right? So this is fine. Finally, we have to check for the upper right diagonal as well. So I'll just go with the for loop here. This one will be equals row minus 1. So this one will be j equals column minus 1. This is also fine. J equals, this has to be, we are going with this one, right? Upper right diagonal. So means we have to go with the column plus 1. So this remains same. I greater than or equal to 0, and j, this one has to be less than n, right? So this is fine. Let me remove row, and this one has to be I minus minus, and j we have to increment, right? So as we are going with the upper right diagonal, so this one has to be j plus plus. This is fine. So if board of I, this remains only j. If board of ij equals q, then we have to return false. So this remains same. Else we have to return true. Else we have to return, right? So this is fine. Now I have misplaced the bracket, I think. So let me do one thing. Let me cut this one and let me give here, right? So this is fine. Let me format this code once. So this is fine. This is looking good. Yeah. Now let's make use of the isSafe method within the for loop, or the backtrack method basically. So I'll just go with if. So let me copy this isSafe here. IsSafe of, let me pass board here, row, column along with the n. This is fine. So within the if condition, we have to place the queen, right? So this will be board of row. So this one column, this one q. This is also fine. Then let's go with a backtrack. So I'll just go with backtrack here. This one. Yep. This one will be backtrack of row plus 1. This is also fine. Board result comma n. So this is fine, man. Now we have just moved to the next row. Next what we'll do, we'll just backtrack, means we'll be removing the queen, right? So I'll just go with board. So this one will be row and this one will be column and this one, let me assign this one to the dot. So this is fine. So we are just backtracking or we are just removing the queen here, right? So we are done with the coding part. So this is it, right? So oh, we have to mention the backtrack method within the, we have to backtrack within the main method, right? So I have forgotten this one. So let's finish it off quickly. So I'll just come here. We didn't start the backtrack at all. We just wrote the helper method backtrack. So I forgot to make use of it within the main function, solve n queens, right? So let's start backtracking from the row 0. So I'll just copy the backtrack. Did I? Or I forgot. So this one will be backtrack 0 comma board comma this one will be result comma, and so this one is fine. Finally will return the result. So this is fine, man. We are done with the coding part, right? So let me run this one. So we have some error, line number 39 just kept true here, so this one has to be returned true. Let me give the semicolon as well. Now yeah, you can clearly see here sample test cases are getting passed. So let's see whether this works for all the test cases or not. Let me hit the submit button, man. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? So I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.